All right, you guys, welcome to tonight's Tech Talk. Tonight we have Jessica McDowell, our favorite TVI O&M extraordinaire. Jessica comes to us from the Marin County Office of Education. And Jess has, basically I invited Jess to do this Tech Talk, recognizing that as TVI, sometimes we hear about these newer technologies. 3D printing is something that's been around for a while, but I think it's a technology that can be less accessible for lay people to use, from designing 3D printed files to actually maintaining a printer, questioning, do I even really need a 3D printer, or how can I just get access to one? And how do I even know what materials would benefit my student in 3D printing? So this talk is really like a layperson breakdown, very practical approach to 3D printing. So obviously this talk is right now for, with the focus on teachers of visually impaired students, but anybody could really support this process. So, parents, other resource specialists at school sites, anybody can really be engaged to support 3D printing initiatives for our VI students. So welcome, Jessica. This is our Tech Talk on 3D printing for tactile and information literacy.
Thank you so much. Hi, everyone. Can we go around? Is everybody part of the class, or do we have other people coming in?
These are all our interns for right now.
Okay, all right. Great, well, welcome. Maybe I'll start where I didn't think I'd start, but as a TVI, I think that my experience with this partly comes from an opportunity that was presented because in Marin we have a technology resource center, and they ended up with quite a large grant. And when Dan Phillips, who's an amazing speech therapist that took on, finding all the old tech and really made a resource that's so valuable in Marin County and very much focused on innovative technologies. I was like, you guys need a 3D printer. And he's like, what, why? And now he's on his second one, and the things that they make for all the students in special ed, like kids in the classrooms that have motor impairments and key guards and all the things, they have just taken off with it. So that's allowed me to access their printer. And I think that I wanted to tinker and play and make. So that was just something that I'm like, ooh, I want to play with this. So that was just something kind of personality wise that, kind of inspired me to mess around with this. I think as I look back at the last few years, I've probably had less projects than I think I thought I would have. Does that make sense? It turns out you really do have to assess. It's not a silver bullet. Like 3D printing is not like, ooh, I'm going to make everything and it's all going to be rosy. But you really have to assess when that's appropriate. So we can kind of chat about that. And I was just on a Google group that I'll share the resource for, the link for, run by Joan Horvath. And in a discussion about how TVIs can work with 3D printing, my takeaways is that we do need to acquire models, and sometimes 3D printed models are just the right thing. But there's it's not easy. It can't just be one person. As a TVI, I think of it kind of like Braille. There are Braille transcribers that are professionals in transcribing Braille. And of course I can make Braille materials, but I don't, it's not my case, not my job necessarily, and I don't have time in my caseload to be really making super high quality Braille and graphics, right? So I kind of feel a little bit of a parallel, well, a parallel with 3D printing. The amount of time to set up printers and to problem solve and do all that, that's you know, it really takes someone in an office, you know, dealing with that. So that's what I'm able to access in Marin, because we have the Tech Resource Center, and I can just email them prints, like here's the file, and they'll get it started printing for me and problem solve when the printer goes haywire and they come back and see all the plastic stuff all over. That said, there are ways that we can dive in, and depending on if you just want to get something 3D printed, what are ways you can do that? And also if you want to start tinkering a bit, if you're so inclined, it's kind of fun. So let me jump to PowerPoint. Then I'll go, whoops, that doesn't do you any good if I don't share that, does it? Okay. So if I go to share desktop, let's see. Okay, you guys are on the PowerPoint now? Or you see that?
Yes.
Okay. So I have, whoops, let me go back. I have a bit.ly link for this, the PowerPoint, and a resource list. And there's actually some 3D files in there. Just so do you guys want to take that down, or I'll share it later? It is http:// bit.ly/3D printing literacy.
Jessica, this is where my iPhone comes in so handy.
Did you
I just clicked
oh yes,
photo.
good strategy, Fran. All good? All right. Oops. Okay. Why are we even talking about this? So I have 4 pictures here, and let me move this out of the way so I can. So what do these things have in common? Ting, you can't say anything. Oh, sorry. So the first picture is a little green bug. It's kind of cute, and which I have a story about him in a minute. And I have there's a spider web and a porcupine and a woolly mammoth. Anybody, any ideas, thoughts? Crickets? No? All right.
This is Emily. These are pictures of things or creatures that a blind student wouldn't be able to touch or feel.
Ding, ding, ding. Yep. Yeah. So you guys may have heard this quote from Josh Mealy. The best types of objects to make for illustrative 3D printing are things that would otherwise be too big, too small, too delicate, or too dangerous to touch. So a great example is a dust mite. Okay, so when I pulled up dust mite pictures, it was just way too gross. I had to put a cute aphid in there. So a great example is a dust mite, which would be too small to touch, or a spider web, which would be too delicate to touch. Or I think you can probably imagine too dangerous and also too big. So that's something that I think as we approach this, we always have in the back of the head, or back of our minds there. So what are models good for? And this is not even just 3D printed models, but what would models be good for? Spatial relationships, and building imagery and understanding of concepts. Tools, unique tools that we use in teaching. And of course, supporting independence and access to the curriculum. And there's assistive technology that's not otherwise available, that is customized to a particular student and task, and it may be cheap to print. Models spark engagement and interest, and it can support a learner's learning style and areas of strength and curiosity and enjoyment. Hold on one second, I keep hitting the wrong button here. Okay. So a couple pictures of examples of these. So illustrative models to provide tactile access to visual materials when a graphic or description is not sufficient. That's one of the criteria I think we're always thinking about. Do I need to go to the trouble of trying to make a 3D print of this? Or is a graphic going to provide the information? Or it could even be described, and that's an appropriate level of access to the concept. Or so the models can provide spatial info and of things that are not experienced in everyday life. When I do searches sometimes on some of the model sharing sites, it's amazing how many people that you know are not really in the field that think they're going to make something for someone who's blind, a model, and it's basically a model of something you can pick up and hold anyway, you know. So yeah, it's a lot of times there might be easier, quicker ways to get a model of something than to 3D print it, right? So another category, which I'll be mentioning Neil, Mackenzie, and Sonoma a lot tonight, are unique tools that are used for teaching and building concepts. Has anybody seen his rotor print? This is a tool that he uses to teach students the rotor when using VoiceOver on an iPad. And it's super cool. He's great at creating either graphics or models like this so that kids get an actual kind of spatial and physical experience with it before they do it on just the flat screen. So that's a great thing that he's designed. Okay. I keep trying to get, can I minimize that? There we go. All right, so other categories, 3D printed accessible tools that provide more independence and access to tasks and curriculum. I'll show you more about this little set of dice. This die is 0 to 5. That's was used in my students' math curriculum for a game. And this assistive technology is another category that Neil excels at. Assistive technology devices and tools that provide needed accommodations. And in Sonoma, he designs things that are pretty unique to each student that fulfill a learning task, a goal for each student that works. Okay, why is it? Okay, so one of the the first thing that I ever did with 3D printing was, let me go, wait. Okay, this is in kindergarten. My student, Logan, who is in 2nd grade now, in kindergarten, and at this school and district, they use a math curriculum called Bridges by the Math Learning Center. And I really like it. It's pretty amazing, but it's very game-based, and there's this number corner program that includes many components, and this pattern calendar is one of them. And each month you get, the teacher's going to put out each day, you know, with the rest of the days blank, and the kids start to think about what they're seeing, and they talk about the concepts, and they start developing what the pattern is. And I'll tell you, sometimes it's like I have to study it a while to like be like, oh, what's the pattern here? So ignore that date, but this is in kindergarten. So basically they're showing a 2-dimensional shape followed by a 3-dimensional solid, a picture, and then they show objects that are the same shape. So it's like, wow. Of course, my kid, with his level of experience with graphics, trying to represent a 3-dimensional shape in a graphic was, you know, there's no way he's going to understand that. So 3D printing, I ended up making this as a 2D and 3D thing, and we just simplified, you know, I just made, this was the the shapes there are, I just made on a pee-off. And I can't believe I didn't even use the straight line tool. I just drew them. So we have square, cube, circle, spheres, rectangle, cylinder. And this was a lot for him to deal with as far as information, but he was exposed to it. And I think I have some videos that you'll see that, over the next couple of years, he's still using these little 3D models and, using that experience then where he just had his hands on it and he's hearing what they're called and he's learning about them. And those are going to continue through, years to come. So yeah, I just said down here, that's like reading the pattern. He's doing left to right. There's the repeated and exposure. He's just participating with the group. And let me go back to that. So, and you see in this calendar, there's dollar bills and clocks and pennies and balls and boxes. And so I brought, the real objects too that we explored and talked about the shape, which the other kids are doing also. That was kind of fun to make a box of like, oh, we have a roll of coins and what shape is that? So that project was really easy because if you go into TinkerCAD, which I'll show you later, is a site that you can make models, they have all these little shapes that are ready to go. And so actually it really didn't take much except for a little resizing, which was basically like cropping a photo, but you have one more plane that you can size. So it's just 3 planes that you're working with instead of 2. Okay. So one thing that Logan really showed me is like how important his aesthetics and his experience was. He describes his tactile world, with words about, beauty and stuff like that. So let me play this little video. And I wrote describing there because he's using language and exploration. And in this, I was a little impromptu, but I'm actually exploring, showing him modeling how I might describe something with very specific language, and then asking him to do the same. So here we go.
Jessica, did you realize I listened very quietly to your describing?
I heard that. Thank you very much. That made me feel like you were really paying attention. Thanks. It feels like okay.
Yeah, so Jessica, I think about the jewel that it's really, really pretty, and it has these points on the side and a triangle.
Oh, can I see the triangle?
It's like triangle shaped.
You're right. I see that.
And it has beautiful curve. It has a beautiful curved point right there.
Mm-hmm.
And then
let me see that one. Is it right right here there
on the top?
Yeah.
So and it reminds me of a jewel because jewels have points on them.
Okay. So everybody, you were able to hear that and everything, right?
Yeah.
Okay. So this is first grade, and we actually have these little solids still that we're using. And on that pattern calendar, the cool thing about the 3D printing is that we can just make a bunch, and I needed a bunch for that calendar. So one material that might be available to us would be like the APH models of these shapes. But those are really large, and it would have been hard in the curriculum to carry those around and really use them. So these were really handy. So this is an assessment. These are, the other kids have a test that show pictures of the 3-dimensional solids that they need to, mark off sphere and pyramid and stuff like that. So this is the next year with him. The way he's doing this test is he's going to find he just has to read, he has to know what it is, and he has to find it on a list. Tell me what it is, find it on the list. Go.
Here.
Okay, put it on the list and then put it on the front.
I'm helping it to roll me down.
Okay.
Sphere.
Awesome. Okay. Then just on his test, I can mark off that he's done that with the 3D model, and that was what, an appropriate goal for him at that point. I wanted to play this one too, quick, it's short, but has anybody heard of magnetiles?
Mm-hmm.
As far as,
Oh, great.
literacy in terms of, in his classroom, he would just play, that would be one of the free choice things. And socially, they would just build things, and he would be right in there building with them and telling their dramatic play stories. So he, during this assessment, which was a little bit of an interruption, but it was fascinating, he describes how he makes a pyramid. So, which if you see in this picture of the magnetiles, how you might put a square down and put triangles on to make a pyramid.
This is how I make a pyramid. Like I put the triangles like on the square, and I like push 3 together, and I put one in the back. So I put 2 of them toward their tops, and then I put the one in the back on the sides of the triangles. I meant on the backs of the triangles. Then I put one on the front.
What a clear description. We can't teach somebody how to do that.
What is this one called?
Well, that's what you got to look for.
It's a pyramid.
Yeah, find it on the list.
Easy squeezy.
Oh, okay. So yeah, he does find it. That was a little bit longer. So, any questions or comments? I just wanted to share this as far as his kind of development with these little models.
Mm-hmm.
Okay. Well, this is the end of second grade. Of first grade, and I'm starting to show him the tactile graphic just embossed of a 3-dimensional figure, and we're comparing it right now to the solid that he has in his hand. And he's not always he's tired here. so you'll see that he isn't always just cute and awake. So there you go. On the page, and see if you can match up what one might be the cylinder. So let me show you the cylinder again. You look at the face of the cylinder, it's kind of like an angle. Take your fingers around the outside. So you have 2 straight lines and shorter lines on top, and then kind of part of a circle up there. It might not be an exact circle on the diagram. Okay. So look for a cylinder on your paper, okay?
Okay. There's no cylinder.
Oh, let's look at it together. Okay. So that one was your cube, right?
Yes.
Let's go to the next one.
That's not a cylinder.
That's not a cylinder.
Cylinder.
Oh, it is a cylinder. Tell me about it. How do you know it's a cylinder?
Because it has like a
long. Okay, so you have like long sides.
Yes.
And what do you kind of see in your diagram at the top of the cylinder?
Like a circular.
yeah, kind of not like an exact circle, but kind of like when you look at it like this, put your fingers on the top there. It's kind of like you see two rounded edges.
Like it never ends.
Oh, you could go around and around?
Yeah, like my finger never ends. It goes around, round.
Very cool.
And it ends right there.
Yeah, going from there to there, it would end there. If you were going around and around and around, you could keep going around, right?
And you would get dizzier and dizzier.
Yeah. Okay, so I know we're talking about 3D printing, but just these little tools ended up being something that just we continued to talk about concepts, and they're just so easy to manage and have, you know, at a moment's notice, just in his desk and things like that. So it was really, you know, the little bit of time spent ended up being really valuable for all the we're able to use them all the time. So there was another project that came up, and his class uses one of the games of their math program was a 0 to 5 die that comes with the teachers had that just 0 to 5 for a math game, and we had the APH, you know, die 1 to 6, and it was like, oh gosh, how do we get a 0 to 5 die so he could be more independent? And I did end up going into TinkerCAD and just basically taking off a 6 off of one side. So I think I can show you just how one might approach that. And let's see. So also, as you're assessing whether you're putting the time, if you do have resources or you're trying to get a 3D print, and you're assessing whether it's worth it, it's worth the time and effort. One thing you're asking is if there's another way to do it. And pretty quickly after this, it ended up that they needed to play a game with a 2 through 7 die. Yeah. And I was like, oh, that one's, I didn't have the time to like pull that off before you guys still hear me, right? Everything is fine with the.
Yep.
Okay, cool. So I realized I did start to go on Twitter and ask if someone could help with a 2 through 7 die, and I realized that there's a Siri can generate random numbers. So let me just do this, and I just taught Logan on his iPad to Siri, give me a number between 2 and 7.
It's 7.
So that just ended up being the quicker, and it was just as independent for him. So there we go. Okay. So in terms of like this project with the die, that was something I was able to play around with and pull off and ask the Technology Resource Center to print for me. Everything I know about TinkerCAD, I learned from Justin in this video. And this is actually 2016, and he's long graduated now, but he just took off. He's extremely visual learner. He learned Braille when he was little, but his whole, who he is, he just ended up using technology. And all 4 years he was in his computer classes at his high school, and really took off with this, with designing things visually. So I'll talk more when we go through a resource list of TinkerCAD is where one can actually make models, but it is visual based and kind of drag and drop based, and OpenSCAD would be a place that you could learn to make models, or students could learn to make models that was more code based and could be done with screen reading software. So let me go ahead and play Justin's video. And he's also going to show a puzzle he made, which I should try and contact him and see if I could get the file, because it's pretty amazing. He'll show it quickly on the table, and what it is a puzzle, but it's 3-dimensional of Mount Everest. So it's got the height, but the base that's on the table is, you'll see, is like the puzzle. So let me go ahead and play this. All good with the sound and everything, right?
Yeah, your sound's coming through good.
Okay, I feel like I'm just talking to my computer. Okay. Yep. It's all good?
Hey guys, it's Justin Geisberger again, and I would like to show you today my 3D printed mountain puzzle of Mount Everest, and I would also like to show you after that how to group shapes on TinkerCAD so you can put a hole in an object. So if you printed it on a 3D printer, you'd have basically, let's say, a box with a hole, which would be pretty cool. So I'm going to go ahead and show you my 3D printed puzzle of Mount Everest. So this took me about 5 months in computer graphics at Drake High School, and I felt very confident in that class, and all the pieces do successfully fit together, which makes me very happy that that works out. And yeah, been doing very good at computer graphics, got a lot of work done, and yeah, so I'm going to go ahead and show you how to group 2 objects together to group a whole. First thing you're going to need is a blank work plan on TinkerCAD. Make sure it's all clear, make sure there's no other shapes. I'm going to go ahead and zoom in here so you can see a bit better. Go ahead and drag this box out so I can show you how to group shapes. So as you can see, it's a solid object, which means if you print it on a 3D printer, it would turn out like just any ordinary box, but printed on a 3D printer in plastic. So I'm going to go ahead and grab this cylinder right here, which is orange. And then I want to make sure this is a hole, so I can put a hole in the box, which is right here. I'm going to go ahead and go over here and click hole. It'll make this a hole. As you can see through it, so that puts holes in objects. But in order to make it so it's noticeable, and you're going to need to shrink this. So I'm going to go ahead and hold shift down and kind of shrink that a bit. I'm going to hold this up just so I can get a better demonstration of how to put a hole, just so it won't mess it up. And so it'll go through all the way. So as you can see, the hole is indeed going through the bottom and the top. So once I have that done, we'll kind of zoom out a little just so you can see it better. I'm going to go ahead and do Apple A, which means select all, or you could also do it like this with the mouse. You want to go ahead and go up here and click group. And if it doesn't work, click it a couple times. So as you can see, I do indeed have a box with a hole in it, which I think is pretty cool, if you ask me. It's like one of the tunnels on a play structure.
I love that reference he makes.
So this is indeed how you group shape on TinkerCAD. I'm just going to do it one more time just so you can absorb the information. I'm going to do the same thing I did last time. This time, so I can have it at a different angle, I'm going to go like this. I'm going to kind of rotate it like this probably rotate it halfway, like that. Then I'm going to bring it over here again. I'm going to shrink it in size again, make it the same as the other one. All right, see, over here. I'm going to kind of bring it up a bit, make it a little wider there, make it a hole again. I'm going to do this one more time just so you guys can see. And yeah, so we got that in place. I'm going to go ahead and group it again. So now, this is even more interesting. not only do you got one hole in this object, but you got two now, so it looks even more cool than it did last time.
It's so cool.
Yeah, that's really cool. So this 3D printing technology has turned out to be a success in my life. I thought it's just been really cool to experience it. And I hope you enjoyed my video today. And yeah, thank you so much for watching this video, and have a great day.
Okay. Stop. Okay. So that was it for the PowerPoint stuff. And you have the link, so you should have all my contact info. So I think I will stop sharing for a moment. And has any comments or thoughts either on kind of the literacy piece and the learning, or have you seen TinkerCAD or OpenSCAD? Any thoughts on anything so far?
This is Leanna.
Hi, Leanna.
Hi, we were just up there for the mapping for 751, and I saw you doing the diagram on TinkerCAD, and it was interesting how he made the holes in that, and I liked how he referenced, like you said, the tunnel and stuff. So that was really cool to see him do it, and it still be accessible enough for that he was able to see everything and show us and how to do it.
Yeah, he is always a very visually, spatially oriented kind of learner. Even during mobility, he would use his phone, and when he would do a route, he would use the satellite view on a map, which to me was completely like way too busy, and I couldn't really orient on it. But he used like the color, even roof colors and stuff. He totally could get oriented. So he's always that's just who he is as a learner. So as long as he can use the accessibility zoom on a big screen of a Mac, he's all over the place. Okay, so I think
I have a question, Jessica.
Yeah.
Just going back before the videos on TinkerCAD, when you were talking about the die and there was not a 1 with a 7 on it. I'm just amazed that you thought to use Siri as the die. Is that what you did? And so then the player, instead of rolling the die, could just say, Siri, give me a number 1 to 7.
Yeah.
And that was the contribution. That was the accommodation.
Right. Which is
I love that. I mean, I just love that.
Yeah, it's pretty fun, and to have something that simple that he's using the technology in the classroom and that the other kids can do too. It really helps, just integrate it. And then, yeah, I had forgotten about the random number generator, and we've been playing some abacus games where we ask for a number between 200 and 500 or something, or, and then he has to set it, talking about place value and stuff. So
it was just something where you didn't have to have the object.
Right.
It wasn't about having the die. You didn't have to waste time with that. You could say, how can we rethink this?
Right.
Have everybody accept that in the circle of friends.
Yes. Yeah. So, well, that's one of the things that you always run into with 3D printing, because we're usually our turnaround time when the teacher tells us something's coming, is not 3D printing turnaround time. So that was one thing that I'll show you on the resources. There's some sites that do have, are trying to provide indexing to other sites and create collections of things where we can get files and find the things we need quicker. But some of the curriculum, like his curriculum, it's all over the country. There's thousands of schools probably, and I'm probably not the only teacher for the visually impaired trying to get accessible materials. So if there was a database, I would start printing his third grade stuff, you know, anything that was relevant to present in a 3D print. I could, you know, look ahead and have some of that stuff made now if that was a resource spot. So that's falls under the category of, you know, some of the stuff we need as TVIs to really utilize 3D printing. And I think that's kind of like having a Braille transcriber, and to have some of these, the infrastructure that, you know, if we need a particular textbook in Braille, we all have the different places that we go and look and, or have to get that made, or however we do it, we do have resources, but that's still being built, I think, basically with 3D printing. Let me go to, I'm going to share my screen again, and there's a resource list that I have. So let me go through it and just show you what some of the links and things are. Is there, before I do that, is there any sort of requests? I can show in TinkerCAD, you know, how I worked with that die. Is there any specific questions that you came to tonight, you know, thinking we might be able to talk about, or?
This is Sandra. I have just one general question.
Yeah.
In high school, I was familiar with regular AutoCAD. I'm assuming it's similar, or how similar is it to the regular AutoCAD interface?
Oh, you know, I have never actually seen AutoCAD, but I guess TinkerCAD is a Autodesk product, and it is cloud-based. So you just, you know, you could log in and you have your account and your things. I'll show you my, when we go into it. So I imagine AutoCAD is just a whole lot complicated, right? And they've kind of made TinkerCAD be something that can be readily sort of played with away. But did you, when you saw TinkerCAD, did that, did you recognize, is there a similarity?
Yeah, it looks similar as far as the interface and how you access it. But a lot of the calculations and stuff are, when I accessed it a long time ago, it was a lot more complicated. You had to know a lot more of the math side to make things work and fit.
Right, right. So have you played with other 3D print, like OpenSCAD or other?
No, not yet. That's why I'm interested.
Yeah, you'd probably like take off with it, right? Okay, so let me share and then go to the resource list. Okay, so I organized this in a way, everybody got that up there?
Yeah.
And let's see here. So there's kind of where to get files for models, general and VI specific, and then ways that you can create models, and then some other more information, reference sites, and then a couple of other resources there. So Thingiverse is a social network and place to upload and download models. This is A.T. Neal Mackenzie in Sonoma, who makes so many great things. So this is his Braille rotor box that you saw the picture of. So if you were to, if you have access to a printer, one thing I was going to discuss is I think it really takes a village to 3D print. There might be resources in maker spaces, in schools, and other, you know, even in the community, and it's just a community that is ready to. It's really about just supporting and providing access. I think that if you walked into any makerspace and they had the resources and time and you said, this is what I need, can we talk about this? You'd probably get an audience and people that could help you out. So if you wanted one of these and you sought out some makerspaces or, and see if you can, you know, get one made. So you could simply go here and you can download the file, and then I'll show you what that will look like if you were to open it in TinkerCAD. I don't have experience with OpenSCAD, but I'll show you where it is and how one would get that. So that is Thingiverse, and just like any other site, you could go and you could search. So if I go back here and I put in Braille, my internet's a little slow there. I don't know why. Did I spell that right? B-R-A.
Yes.
D. That's strange. Really? Huh. Well, okay. We're just gonna go. We'll do the same search on TinkerCAD. So TinkerCAD is the design aspect and also share and social. So you saw Justin working on that. This is the link to Neil's TinkerCAD page. And he, on his TinkerCAD page, one thing that's cool that he has that I printed for a student is, are you guys familiar with Swift Playgrounds on the iPad? It's the coding game, and it's accessible with VoiceOver and having a 3D model. So if I open up the board pieces, you saw there was a grid that represents the Swift Playgrounds grid, and then these are the little pieces that you could put on the grid to have a tactile representation of that world, so that the mapping of it, the student can learn about the spatial relationships and map it out and understand the direction and going up another level and things like that in a tactile form as they learn about the using VoiceOver and going through the coding game. So that's a really cool resource there.
Yeah.
So let me continue. I'll come back to, oh, I was going to search here. This is a cool, if you have a large iPad, this stand is really cool, that holds the iPad up. And he also, it might be another file, but there's a stand that holds a piece of paper that you want to scan. So that's super cool. So he's great at like building these tools, designing the tools that can fulfill a specific need that, oh, there it is. This is the Pro stand. I think it has a couple parts. That's the other part that might hold the paper. Something. So if that was something you had access to a printer and wanted to try and print or see a picture of, we could contact Neil and get more information about it. So I was going to do the search here real quick. So 3D designs, let me search. And if you put in Braille.
Oh my goodness.
Someone made a Braille laundry. This is the kind of thing you're going to be like, no, I'm not sure about that. The Braille doesn't really work, but you know, people are trying. But you know, you can look through, and there's a lot of experimentation that you would need to do if you printed this one. It looks okay. Oh. This is a gaming die. So it looks like you might be able to feel that, but some of them, you know. And also there's a whole discussion to be had about Braille in 3D printed plastic. it works much better if you don't print flat, because it tends to be kind of pokey and sharpy. It doesn't feel great. So a lot of people are like, well, we're going to put Braille, 3D printers, yay, we can print Braille, but it may not be the best. That's not maybe the best presentation of Braille, but okay. Let me go back to the resource list. Any comments, questions about that? No. Yegi, I guess it's called, is another site that I believe, it's kind of like the Google of 3D files. When you search, it goes to other sites beyond this one. So just something to know about. So VI specific sites that you could find models, there's Tactile, and the folks at btactile.com have they have libraries that they are tapping into when you search, and these libraries around the world are focused on models that people with visual impairments would use. So this one's cool in that you still, users are putting models up here, and it's not like everyone has been fully field tested with people who would try to get information from them. So not all models are working, or they may not all be helpful or useful. You know what I mean?
Yep.
Like, I don't know, this little Beethoven bust here is going to provide too much information for someone. Like, do we need that? I don't know. But look, you could print a Braille swing cell. That's kind of cool. Okay, so that's that. And we'll go back to the resource list. The APH Tactile Graphic Library. When you go there, you do set up a login. And I've found, I haven't spent much time here, but I found it's mostly replacement parts for APH products and a couple other things. But the tactile graphics there's a large database of tactile graphics that you could do, print, run through a Swell P-off machine. That's really cool. It reminded me, like, oh, I should go, like, lots of maps, and if you needed someone was doing a report on a country, you could go get some different maps that are either labeled or just outlined. So that's a cool resource, especially for the images. There's not a whole lot of 3D prints, but maybe they would be adding to that. Something to know about. And these two are more technical sites to get and share models. So I mentioned at the beginning Joan Horvath, and she's really a pioneer in thinking about how 3D printing can be used in education, and how even in any learners this is another mode of learning, not just talking about kids with visual impairments or people with visual impairments. It's using your hands as another way to know about a concept, and they do very like calculus and some high level math stuff represented in models. So I mentioned that because she and what's his name, Rich Cameron, have their consulting firm is Non-Scriptum, and so this is a link to what was his name? Rich's GitHub, and this is where he has OpenSCAD designs. So OpenSCAD is like TinkerCAD, where you're using more code instead of a drag and drop options. So let me see if I can open a project. Let's see, overview repositories. Let's see. So here's his calculus models. So if I click, I'm way beyond my pay grade here and like what's happening this, but this is the code basically for what he's designed, which is part of the model that's has a representation for the calculus concept of it. And that was a really probably embarrassing layperson's term trying to describe what was what he's made there. But so this is the link to GitHub where people are basically sharing code and stuff like that, I think. So the other site, you imagine, I think is another sharing site. This is his page again, and you could see that he's made some Braille alphabet tiles, and he's printed these vertically. I mentioned that Braille on the plastic 3D print can be uncomfortable, but they did do some research, I believe, right, Ting? Or Ting, did you do the research? When you make a design and you have Braille on the plastic, if it's printed vertical, the dots tend to be softer and better to read. So that looks kind of like TinkerCAD there. And we are 1 minute from 8:30, and I'm rambling on here. So the places to create models, TinkerCAD and OpenSCAD. And there's a blog in there from Non-Scriptum, which is informative about 3D printed teaching models. The Diagram Center will probably be a site in the future that we could like Bookshare for books, like the image share, right? And go back. Then there's a couple more links there. There's a Google group, 3D printed education models. And Joan Horvath developed that. And it's meant to be a place that teachers can ask for models and people can go on and produce models for teachers. So use that. And then there's also a good video from Rich and Joan on that page. Okay, let me go back to stop sharing screen. I did not go into TinkerCAD and play around like I said I would. But we're at 8:30, so any questions, discussion?
This is Tarina. I also was at the lab and saw the dice. It was fascinating. But it just got me thinking about other ways to adapt. Like when you were talking about touch screens, there are so many touch screens everywhere, like microwaves and washing machines and like living skills, things that our students have to deal with. And it got me thinking like, I wonder if there's a way that we could use this technology to help access that more. Just something, a place that my brain went, I started thinking about. So.
Yeah, I think that's a good place to go with, thinking about it. In the technology resource center, since they work with students with a lot of motor impairments and stuff, the key guards and other tools that they're able to make, they really can customize them. And I could imagine that might be a overlap there too of what you said.
Great, Jessel. Thank you so much for putting together that resources list. And I think just knowing what's on that list and how to utilize the resources you shared will be very valuable.
Okay, good. Yeah, I hope there was stuff in there to get you thinking about it and maybe diving in or seeing what's around in your community if you're not already linked up to some options.
And the right file for 3D printing, and then you can check in with your local library, local makerspace. Some middle schools and high schools actually have like a 3D printing club, and so you can get help getting the thing actually printed. But where your expertise comes into play is actually figuring out like the appropriate file or like design of a 3D model, because it can otherwise be a pretty big like time suck to and money suck to buy the actual 3D printer and maintain it like yourself or even within your VI program, unless you have an AT specialist who can be dedicated to supporting the equipment in the VI program.
Yes, I think you would need the money and the time. It wouldn't be something that, it would be really hard if there was a department of, you know, full-time VI O&Mers and we're just going to get a 3D printer, and then, you know, if there's not really hours already set aside for somebody to be working in that office and problem solve, and you definitely need a community. You know, it's not just like a regular printer, you got to problem solve stuff. So
all right, well, thank you so much for joining us, Jessica. This is great. And it's good to see everybody, TVI interns.
Thank you, Ting. Thank you so much. Thank you, Jessica. Really great to see you. Thank you, everybody. It's nice to see everybody.
yes.
Good night, everybody.
Good night.
Bye.
Thank you.
Jessica McDowell, teacher of the visually impaired and certified O&M specialist, Marin County Office of Education. Twitter @JessTVIONM.